Good morning. This is Dr. David A. Padgett. Today is March 31st. This is World Regional Geography 1010, Section 98B. We'll start off by sharing my screen and with a couple of housekeeping points of information. So again, this week, you are working towards the completion of Research Quiz 3. And I will shift in, I'm in student mode as is. So you go here, here, and then here's the research quiz and the answer sheet. We've done 2 of these previously, so you should pretty much know the drill. If not, please ask questions, email me, call me, get in touch with me, what have you. The quiz is due at 11 o'clock a.m. on Friday. Just make a note of that. The resources for the quiz are located, as usual, in content. And so if you notice, this quiz focuses upon the population geography of Latin America and the Caribbean. And so if you remember, the population geography of Latin America and the Caribbean is covered in the lecture recordings from last week, and that would be lecture recording on March 22nd and a lecture recording on March 24th. And of course, the reading assignment on Latin America population geography. So those are included in your reference information along with other associated with the quiz for the course. Again, if you have any questions, let me know. Read the instructions for the quiz very carefully so that we don't have any misunderstandings. Also, just remember that you do have an article review due on Monday at 11:30 p.m. Please make note of that. Okay, so with that being said, let's move on to this week's lecture materials and discussion materials. If you remember, during the last class period, we started by looking at the climate of Latin America and the Caribbean. Oh, excuse me, I'm so sorry. Which took us into the textbook. So we went to the textbook and we made note of the and so we of course started off in chapter 11 and the and we started off primarily looking at the Köppen climate map for Latin America and the Caribbean. And we made note of the fact that the region is dominated by tropical rainy climates. And we also noted that there is a significant presence of B climates or desert climates here along the US-Mexico border. And of course, along the west coast of South America is where we find the Atacama Desert here. So again, we have the Atacama Desert along the west coast of South America. we took a quantitative assessment of these regions by looking specifically at the climate graphs for Lima, Peru, shown here, and we made note of the fact that Lima, Peru only receives 0.6 of a millimeter of precipitation per year, 0.6 of 1 millimeter per year. And so you can see how that low rain amount clearly illustrates the fact that the Atacama Desert is one of the driest places on Earth. We refer to the Google Maps, and we looked at we compared Iquitos, Peru's climate and location to that of Lima, Peru. We delved into ArcGIS Online. Again, this is just reviewing from last time. And when we looked at ArcGIS Online, we went to Lima, Peru. And made note of the fact that Lima, Peru is in relative close proximity to Iquitos, Peru. We used the measure tool. And notice that here from Iquitos to Lima, straight line distance is about 600 miles, or about the same distance it is from Nashville, Tennessee to Orlando, Florida. But we noted that, if we go back to the climate map for, I think North America is included. If you notice that for where we are in Nashville versus Orlando, within that that 600-mile distance, those two cities are within the same CR, subtropical permanently rainy climate. However, if you notice, the Iquitos, Peru is in the AR climate region, or tropical permanently rainy climate, and Lima is in the desert, BW climate. So drastically different climates, and we can, between those two cities, and if we go back and look at the climate graph for Iquitos, Peru, we can see how different these two actually are. If you remember, Lima, Peru only had 0.6 of a millimeter of precipitation. Iquitos, Peru, it's substantially more centimeters, or if we translated this into millimeters, this would be 600, 500, 400, 300, 200, 100 millimeters of precipitation. So it's clear that Iquitos, Peru is a much wetter climate region than is Lima, Peru, and we referred to this diagram here that illustrates the rain shadow effect, which specifically explains why this difference exists. in that we have the prevailing winds for the region, the southeast trade winds coming off of the Atlantic Ocean onto the eastern shore of South America up through the Amazon River Basin. That air is forced upward as it climbs over the mountains, and as it's forced upward, it gets cooler, condensation takes place, and then, of course, we see clouds forming and rain on the windward side of the mountain where Iquitos, Peru is. So that's why Iquitos gets a lot of rain. On the other side of the mountain, this air continues to move, but now it's very dry as it reaches the leeward side of the Andes mountain range because the moisture has precipitated out. And so now that very dry air contributes to the formation of the Atacama Desert, which again is one of the driest regions on Earth. And so this phenomenon is known as the rain shadow effect. So you essentially have these Andes mountain range blocking rain from reaching the side of the mountain where the Atacama Desert is. So that's just to review a bit of what we talked about last time. But as you can see, if you notice, if we go back to the map of the Köppen climate regions, there are several different types of A climates. So there's the tropical permanent rainy climate that we saw characterized by Iquitos, Peru. There is the tropical monsoon rain climate AM, and then there's the AW tropical summer rain. So the AM and AW climate regions are regions that have a seasonal pattern of precipitation, or they have only two seasons, a wet season and a dry season, not winter, spring, summer, fall, like we do. So if we take a look at a place that's located within that AW climate region, we get here the city in Brazil. And as you can see, if we look at the precipitation amounts, now I must stop here and say that in climatology, the year is broken up into only two seasons, winter and summer. And so the summer months are April, May, June, July, August, September. The winter months are October, November, December, January, February, and March. So you have 6 summer months, 6 winter months. If you notice, for Cuaba, Brazil, the precipitation amounts for January, February, and March are pretty substantial. So we have 200 millimeters, maybe a little over 200 millimeters. That translates into about 10, a little bit less than 10 inches of precipitation for each of these months during the winter. And also for October, November, December, we see around just a little less than 10 inches of precipitation, 200 millimeters. If you consider that there are 250 millimeters or 25 millimeters per inch, 250 millimeters would obviously be 10 inches or a little less than 10 inches. But if you notice, conversely, during the summer months, there's there's much less precipitation, but very little in June, July, and August. And so this is a seasonal pattern of precipitation here illustrated by this climate graph. And so we have, again, a map of the various A climates. And then we also have climate graphs representing the differences between at least the AR and AW climate, Köppen climate regions. One with seasonal precipitation, one with precipitation every month of the year in ample amounts. So looking at the climates of the region, and how they are affected by the Andes mountain range. The Andes mountain range is obviously not the only mountain range throughout Latin America and the Caribbean. The region is very mountainous, very much human life is impacted by the mountainous nature of the topography, as is the vegetation. And so we'll look at this simplified altitudinal zonation graphic here to start, and then we'll look at the one that's in the textbook, which is a little bit more complex. But in simple terms, altitudinal zonation is when we have climate zones, different climate zones forming at different altitudes in places where elevation is high, let's say, or relatively high. Now, this entire region, Latin America and the Caribbean, almost the entire region is in the tropical zone on the Earth. And so that tropical zone tends to be very hot, warm, and we would expect the types of climate that we see here at 2,500 feet and below to sea level within the Tierra Caliente zone. So this is a cross section of the Andes mountain range. So just imagine if we just slice the mountain range in half, and we're looking at various zones of vegetation and agricultural activity in and around the Andes mountain region. But again, these mountains or high elevations are found throughout Latin America and the Caribbean. It's very mountainous terrain throughout. So the Tierra Caliente, of course, caliente means hot in Spanish. This tropical rainforest vegetation is what we would expect to see throughout the region. However, as we move farther away from the Earth's surface, the influence of gravity becomes less upon atmospheric gases. And so those gases, less under the influence of gravity, expand. When gases expand, they're less capable of holding heat. And so the temperature goes down. So temperatures fall as we increase in altitude. And so that has a direct impact upon the vegetation that we see at various elevations, and also the type of agricultural activity that human beings engage in. And so notice that in the tropical rainforest, at the low elevations, we have these large plantations of bananas and sugarcane and the types of crops that we expect to receive from the tropical region. As we get higher in elevation, another common crop, coffee, is found. So the coffee crop is a higher altitude crop. And then when we get higher, we get into the Tierra Fria. There are more hardy crops, tubers such as potatoes and barley and wheat. And then, of course, when we get to the Tierra Helada, above 12,000 feet above sea level, then that's where we have more grazing and livestock agriculture taking place. And at the very top of these mountain ranges, the Tierra Nevada is where we find the snow line, perhaps continuously white peaks throughout the year. The textbook also has a graphic depicting the a graphic of the altitudinal zonation phenomenon. So here it is. So this is figure 11.11, altitudinal zonation of vegetation and crops. This is a little bit more complex image compared to the one I just showed you, but you can clearly see that with higher altitudes and elevation, we have a change in the plants that we see. As we get higher and higher in elevation, we also see a change in the types of crops that are dominant at different elevations. And so again, this is an earth science tradition related phenomenon. Altitudinal zonation is also a human land tradition based phenomenon, in that the elevation dictates the types of agricultural activity that human beings engage in throughout Latin America and the Caribbean. Also, most humans reside in the Tierra Templada in Latin America and the Caribbean, because the Tierra Caliente is very hot, it's not comfortable. Most people live at higher elevations. That's where most human population is found, in Latin America and the Caribbean, above 2,500 to 3,000 feet above sea level. So again, the climate of Latin America and the Caribbean has direct impact upon vegetation regions. And so here is a map of various vegetation regions. And so these vegetation regions respond directly to climate because plants have tolerances that are based upon precipitation and temperature. So there's a certain amount of precipitation and temperature that certain plants can thrive within. If they get outside of those areas, they tend not to survive. And so they're limited by precipitation and temperature. Of course, precipitation and temperature are the two main elements of climate. And so if you notice, given what I've just said, on the west coast of South America, where the Atacama Desert is located, we of course find desert and xeric shrublands. So these desert plants are adapted to that kind of environment. They can survive in environments that receive less than 10 inches of precipitation per year. And in some cases, they are able to they be dormant for years until they come in contact with water, and then they will bloom or what have you. This southernmost region of South America is the Patagonia Peninsula. So that's the Patagonia Peninsula. And notice it is dominated by this Pampas region, which is this kind of pink color area symbol. The Pampas region is somewhat similar to the Great Plains of North America. It's grasslands and shrublands throughout this vast region, very similar to the Great Plains of the United States and Canada. And it is also a major agricultural region, just like the Great Plains in our part of the world. So, and of course, the rest of the region is covered by tropical forests and tropical broadleaf forests, which, as you can see, there's an additional layer on this map of point symbols that are show where deforestation is taking place. And so in the textbook and in on this image, we have attention paid to the deforestation issue. So here we have, get to it. So here we have figure 11.39, which is a remote sensing satellite image in the western Mato Grosso region of Brazil. And you can clearly see that forest has been cleared away for cattle ranches and soybean farms. And so the beef industry has grown significantly throughout Brazil specifically. And, so the next time you go to Wendy's or McDonald's and get a double stack or whatever they sell there, there's a possibility that that beef came from somewhere in South America, not a ranch in Texas. So you can see how destructive this practice is. The natural state of this land, of this soil, is not for feeding cows and cattle. This was a rainforest, perhaps, and now the soil is being used for something that nature did not intend it to be used for. And so the potential result, is the ruination of that soil, which we defined earlier in the semester or earlier in this unit as desertification. So this is exactly how desertification occurs, when humans misuse soil. And eventually this soil will be incapable of providing food for the cows, incapable of doing anything. And then it's just ruined. And that's the definition of desertification. We can see it illustrated here at figure 11.39. So through this remote sensing image. So getting back to the core content again, focusing upon climate, let's look at this image. This is the, as you can see, this is the Earth. It's a color area symbol image with red, with red representing warmer ocean temperatures, and of course down to the greens and light blues representing cooler ocean temperatures. So you've probably heard something about El Nino. What is El Nino? El Nino is a climate phenomenon that occurs periodically, which begins with the warming of the equatorial region around the Pacific Ocean. Yeah, that's how it starts. And so this is a satellite image showing, it's a thermal image showing the difference in temperatures in and around the equatorial zone of the Pacific Ocean. And you can clearly see that the temperature around the equator is elevated above normal. It's elevated even above its normal temperature. So this is an illustration of El Nino. Now in the textbook, there's also a graphic diagram showing what happens during El Nino here at figure 11.4. And so you might ask, well, okay, so what? So the Pacific Ocean gets warmer periodically. Why is that such a big deal? Well, the Pacific Ocean by itself is half of the world's ocean area. So just the Pacific Ocean is 50% of the world's ocean area, and the world is covered 70% by water. So if the Pacific Ocean is 50% of the world's ocean area, and the entire world is covered 70% by water, any major change in the Pacific Ocean is going to have global implications. So what happens is during El Nino is when that warming occurs, places that are normally very wet or get lots of rain have droughts. places that are normally dry have torrential rains and flooding. Uh, there are all kinds of effects on a global scale related to El Nino that can, in some cases, be quite destructive. Um, Now, if we look at the uh, the schematic, what you're seeing here at the figure 11.14a is the Pacific Ocean under normal conditions. So normally the flow of water is toward the west, from east to west. And that is due to the fact that we have in this region, if we go back and look, the ocean currents. So we have the equatorial ocean currents, warm currents flowing from east to west here normally. That's what normally occurs. And we also have the, if we look at the wind belts, so the world wind belts, if you notice, in the tropical region, normally flow from east to west. That's under normal conditions. But as you can see in the textbook, during El Nino years, that flow is reversed. And so that results in several interesting things happening. It shifts a lot of weather patterns and climate patterns globally, and has caused for a number of problems. So you can imagine that a place in the world that is normally very moist, if it goes into a drought period during the El Nino years, you can see how that can result in uh, starvation. It can result in illness. You know, even if people don't starve to death, if they're hungry, or if anyone's hungry, one of the first things that breaks down is your immune system. So you don't have enough food, you become weak, your immune system breaks down, and now you're vulnerable to all kinds of diseases. So you might not starve to death, but you might die from a disease that overwhelms your immune system because you didn't have enough to eat or drink. And so that's one of the problems that's associated with El Nino. Now, fortunately, as I showed you here, um, we have, as I showed you, the ability to predict the onset of El Nino using remote sensing technology. So now with satellites, we can note the onset of El Nino, and we can climatologists can warn governments and the world that El Nino is starting. We can see it on our beginning on our satellites. Here's what we need to do to prepare for impending drought. Here's what we need to do to prepare for impending floods, because we can look back historically and see what happened during past El Nino events. And so we can put out warnings. For North America and the United States, El Nino has impacts in a couple of ways. On the west coast of the United States, there are higher and rougher tides during El Nino, much more aggressive tidal action during El Nino because of the reversal of the direction of flow in the Pacific Ocean. What has occurred in the past during El Nino years prior to the satellite technology being able to forecast the phenomenon is that a lot of people would be killed and injured in the high tides on the west coast of the United States. Most of you being from the Southeast have probably been to the beaches in Florida, maybe Destin, Panama City. Maybe if you're lucky enough, you went to Daytona or Miami. But most of the beaches in Florida have a very gentle slope The wave action isn't really extreme most of the time. Um, that's very different from California beaches, where it's not uncommon to have 4 and 5 foot waves, sometimes 8 foot waves. People can very easily be swept up and killed. The ocean floor drops off much more quickly into deep water on the West Coast. Um, and so under ordinary conditions is dangerous. During El Nino years, it's extra dangerous. But fortunately now with satellite technology, we can make warnings to uh, beaches and municipalities that have beach front property. And in some cases, the beaches are closed. When the ocean is too rough, people won't even be allowed to swim. They just say it's too dangerous. We know this because it's an El Nino period and you just need to stay away. Also on the West Coast, you'll notice landslide California homes. A lot of people in California like to build their houses on close to the ocean. You have a nice ocean front view. Unfortunately, when there's increased tidal action along the West Coast, you see what happens. People's homes wind up sliding off into the ocean. And in some cases, people have been actually killed by these slides. So, of course, the risk of this occurring in California is higher during El Nino years, and so during El Nino years, a lot of building permits are denied in landslide prone regions, whereas maybe ordinarily they might not be. But yeah, during El Nino years, there's a lot more concern is uh, placed upon building in areas where landslides may occur. And so, or there are warnings put out, to people who live in these areas that it might undergo increased erosion. Um, so El Nino does affect parts of North America in that way, in a bad way, but in a good way, because El Nino results in the reversal of the trade winds. It mitigates the impact that hurricanes have upon North America. Hurricanes ride trade winds from east to west. And if we go back to the 2021 hurricane season, you'll notice that the 2020 hurricane season was a record-breaking season, more hurricanes than we'd ever seen before. I think there were 9 or 10 that had made landfall in North America and the United States. And 2020 was not an El Nino year. 2020 was the opposite. It was La Nina, where there's a cooler than usual temperatures in the Pacific Ocean. So El Nino, the male child, La Nina, the girl, that's the opposite. Where does the term El Nino come from? Well, long before we had satellite imagery, fishermen off the coast of South America would notice a change in the types of fish they caught as the water temperature changed. So some fish like cold water. So because under ordinary circumstances, the west coast of South America is influenced by the Peru current, which is a cold current, which brings cold water from the Antarctic region north along the west coast of South America, because that is the norm. Fish that like cold water were normally the ones that were seen and caught along the west coast of South America. During El Nino years, when this pattern was reversed and we had the warm water from these equatorial currents flowing south, now there's a different kind of fish, or maybe no fish present. And so fishermen, even before we had long before satellite imagery was uh, available, hundreds of years ago, saw that this change occurred, and they called it El Nino because the change normally occurred around December or Christmas. So El Nino literally is the Christ child. It's Jesus, right? So that's why that's called El Nino. Now, obviously, the opposite occurrence is La Nina, which is what we had last year. So now you have a stronger flow of west to east equatorial trade winds, and that pushed all those hurricanes into North America. So during La Nina years, higher hurricane risk. During El Nino years, we have lower hurricane risk in North America. So this El Nino pattern is good for those of us in North America in that it mutes the formation and transit of hurricanes. So again, this El Nino phenomenon has global implications in terms of weather and climate uh, throughout the world. Let's see. So speaking of hurricanes, one of the most devastating hurricane. Well, the Caribbean is visited by hurricanes quite often, but one of the most devastating and deadly hurricanes in history was Hurricane Mitch, which struck, as you can see, Nicaragua and Honduras. It was a Category 5, the highest, most powerful hurricane in terms of the Saffir-Simpson scale. And in 1998, it struck Central America and killed at least 11,000 people. And so because many people were missing, because if you remember, a lot of the lower income people in Latin America live in the favelas in those hills, which if they become liquefied by precipitation, there are mudslides and landslides there. Many more people living in densely populated areas in those favelas. And so once a mudslide happens there, people are just buried under debris, and maybe they were never found. So there were at least 11,000 people killed by Hurricane Mitch. If you remember, the death toll for Hurricane Katrina was around 1,500, and that's not just in New Orleans, that's throughout the Gulf Coast region. That was about 1,500 people as compared to 11,000 from Hurricane Mitch. Again, people are regularly killed in mudslides due to tropical storms in the Caribbean. A, there are just more tropical storms there. B, people in poorer countries don't have all the warning systems that we have. We have apps, we have television, we have radar, we have all kinds of warnings. We know a week, 2 weeks in advance that a hurricane might strike our region, especially if we live on the Gulf Coast region. Places in Latin America and the Caribbean that don't have our wealth, they have no warning. And so it starts raining. The next thing you know, your house is collapsing in on you. And that's pretty much how it goes. So that's why tropical storms like Hurricane Mitch and other hurricanes that strike the Caribbean region can have much more deadly consequences than they do here. Okay, so I believe that I have covered pretty much everything that needed to be covered. Except for a couple of things. So you notice at the end, there are two presentations about focusing upon global urban climate vulnerability. We've been through this content to some degree, but if you notice, the presentation here will provide us a segue into next week. So next week's assignments will emphasize, in part, the GLOBE program, which is a program for pre-service teachers. So the pre-service teachers will begin next week to explore the GLOBE program. GLOBE stands for Global Learning and Observations to Benefit the Environment. And so this presentation emphasizes how the content of this content, which focuses upon urbanization and climate change and how they are coming together to be at the heart of a potential global crisis, how that content can be used in the classroom. And so our project here at Tennessee State University has its goal of closing the Black STEM achievement gap. STEM stands for science, technology, engineering, and math. We know that, for instance, there are only 3% of doctors in the United States are Black. And you might think, well, so what? So why do we need more doctors? Does it matter what color your doctor is? Well, statistically and historically, yes. African Americans who earn MD degrees are far more likely to work in medically underserved communities than other people. Far more likely to do so. So in order for us to have more doctors, we need more Black teachers teaching science, not just teachers, but Black teachers. Studies show that we, or any ethnic or racial group, tends to do better in science when we have science teachers who look like us, so who speak our language, if that's the case. So our goal here is to work with pre-service teachers such as yourselves, if that's you in this class, and try to get you to consider becoming a science teacher. Now you might think right now, well, I just want to teach. I don't know anything about science. I'm bad at science. You don't have to be a scientist per se in order to teach science or inspire a child towards a career in science. And none of us would be where we are as scientists. I wouldn't be where I am without teachers. None of us would be doing anything without teachers. And so this program, this project, is aimed at bolstering confidence in pre-service teachers so that you might consider becoming a teacher and helping us close this achievement gap in racial achievement gap in STEM. And so we use this content that you've been through. You can use it in the classroom, even at the K through 12 level, primarily with GLOBE as the main conduit for delivering the course content and delivering the curriculum. And so our project is extended for another 5 years. We've been with this project for 5 years. We have a number of partners. We're the only HBCU that's involved in this part of the Mission Earth project that is funded by NASA. And so here is the framework for implementing the curriculum through both HBCUs and informal education institutions such as museums, community centers, churches, boys and girls clubs, so on and so forth. And so again, our goal is to get more pre-service teachers involved in science. teaching. Now, ordinarily, this project is very hands-on. We go outside, we do trainings, uh, we collect globe data or atmospheric science data with high school students. So first, I, as a globe trainer, would train you as a pre-service teacher, and then you would go outside to, we would all go to either, we used to go to Pearl Cone High School in Nashville. Sometimes we would go over to Stratford High School in Nashville. Of course, with COVID-19 and the pandemic, we're not able to do that this year. So here's just some more of another activity. We would go out and collect globe data and work with the young people to create ArcGIS Online maps of the data. This is called a near peer learning activity, whereas because you all are close to the same age as these high school students, they tend to want to emulate you more than they want to emulate me. And so they see you, even if you are a not planning a career in science, I take all the students to the school so that they can see uh, that you are a biology major that looks like them at Tennessee State University, or you're a chemistry major, or you're an engineering major at TSU, looks like some of these students, and they might aspire to be where you are in 3 years or 2 years, whereas trying to be where I am in 30 years just doesn't even seem conceivable, right? But they can say, oh, here's Johnny Brown, he's a engineering major at Tennessee State University, and he's 20. I'm 16. I think I can do that, right? And so that's the emphasis of the near peer uh, teaching strategy. And this is what we would normally do: is take a field trip out to one of these high schools, engage with the students, and then a globe data collection experience. And the emphasis is upon urban heat. That's the main focus, to get the students' attention with regard to the global warming issue. Global warming is oftentimes presented as glaciers melting and polar bears losing their habitat and sea level rise. None of those things are happening in Nashville. We don't have sea level rise in Nashville, no polar bears, no glaciers, but we do have air pollution. And climate change and global warming can exacerbate the negative health effects that visit humans in the form of asthma, COPD, and there's even a relationship between air pollution and COVID-19 that has a higher impact in communities of color than other communities. So there's also that factor that we've added into this as we've continued to work in schools, even during the pandemic. Uh, we recently did a project in Detroit with some young people from ages 13 to 18. It was, of course, a virtual activity, but it was based in this same concept of urban air pollution, and we used the globe protocols to collect the data. Uh, Heat kills more people than any other weather-related hazard. And so that, again, grabs the young people's attention. And then we collect globe atmosphere data like such. And then here's some pictures from past years where maybe 2019, I'm pretty sure, where we were out interacting with the high school students, collecting data. I mean, this is the way that science should be done, but it's a pandemic year, so it is what it is. Um, GIS applications with the high school students. And here's an image showing this is a screenshot from a Zoom meeting that we had with the high school students prior to the pandemic. So we were taking the results of the mapping of the globe data using ArcGIS Online and sharing that process and methodology with the students in this remote Zoom virtual format. We were doing this before COVID. And the reason that we did this virtually after going to the school is because of time constraints. It's very difficult to get time in a high school or any classroom just because of the way that our schedule is versus the school schedule. So if we can get over there for 1 or 2 days and do this outdoor exercise, the rest of the time we can analyze the data and our results virtually. And so we've done this several times. And so, again, here are our objectives. And so here's another image from our work with these schools. We're also going into informal education institutions, again, after school programs, boys and girls clubs. Uh, these informal education institutions that are outside of the normal public and private school infrastructure give us a lot more flexibility. So, for example, we can do things on Saturdays. The project that we did with the children in Detroit was on Saturdays. Public schools normally don't meet on Saturdays, aren't going to meet on Saturdays, right? So working with these informal education institutions gives us a lot more flexibility. Um, and so this project is continuing, and we are working with schools now, not with institutions now, not just in Nashville, but all over the country. Like I said, Detroit, Atlanta, we're in New Orleans, we've expanded into Richmond, Virginia, and so on and so forth. So we're going to expand this into a national mission. So hopefully that gives those of you who are planning careers in teaching a little bit of background on our global urban climate vulnerability project. And so next week, like I said, you can refer to this document as you work through the assignment that's related to GLOBE for next week. So I believe that, I didn't mean to stop my share. I believe that we have pretty much covered everything. Just one last point of information before we go. Again, just housekeeping here. Continue to work on the Unit C research quiz. I will post the lecture recording for today as soon as possible. The lecture recording for Tuesday is already up. Don't forget, article review 6 is due on Monday. Does anyone have any questions at this point about anything? Okay, if you think of something later, or if you're listening to this recording and you think of something, please get in touch with me. I will be right here. Several of you have been asking questions. Keep it up. And so I'm going to stop the recording now. Thank you for attending and have a safe weekend.